I want y'all to talk to me. We're talking about some zombies infecting. I don't even know where it's at. It doesn't say. Oh, it says. Nope, doesn't say. All right, we got a zombie apocalypse. Everybody listen up. Strain A says the original zombie, which means we start with how many zombies? 1. If it says the original, that means there was 1 zombie to start with. So in your table for strain A, you should have put 1. Now go back and read strain A. It says each minute, the original zombie can infect how many new people?
3.
Reading is hard. Thank you, Gwyneth and Amaya. Good job, baby. Each minute, make sure we're paying attention, Skylar. Put your cup down. You can't multitask, girl, so you got to pay attention. Each minute, the original zombie infects 3 new people. If we start with 1 and we infect 3 more people, how many zombies are there now?
4.
Good, Michael. 4. If they go and infect 3 new people, how many do we have now?
7.
7. So strain A says the only zombie that can infect anyone is the original zombie. Okay, make sure you're with me, boo. So it's going up by 3 each time. Is this the table y'all got for strain A? Check yours. If it's not, you need to change it because this is what you should have gotten for strain A. It starts with 1 zombie and he infects 3 new people every minute. So it should be going up by 3. I'm going to write +3 just in case you need to see it. So everybody good? All right, let's talk about strain B now then. Strain B says each minute, every zombie is able to infect 1 new person. So if we start off with the same zombie, but each minute, every zombie can infect 1 person. Let's talk about it. If Curtis is a zombie and he comes and infects me, how many zombies are there now?
2.
2. All right. Me and Curtis are zombies. Now, the next minute, me and Curtis can both go infect people. Curtis, who you want to infect? I knew it. Jay, I'm coming for you. So now we got me, Curtis, Jay, and Amaya are zombies. How many zombies do we have?
4.
4. Now the 4 of us can go infect somebody else. So how many are we going to have next?
5.
Ooh, all 4 of us can go infect people. Thank you. I choose Tay because Tay's smart. She'd be a good zombie. Curtis, who you choosing next? Chandler. Chandler, you a zombie. Jay, who you choosing? Kiera. Who you picking, Amaya? Who you pointing at? Carter, Summer, Skylar, Michael. Summer, you a zombie too. So look, there's 8 of us now. What kind of pattern do y'all notice strain B has?
A multiplying.
It's doubling times 2. Very good. So what would come next if all 8 of us go infect people? 16. What would come next? There we go. 32. What would come next? Good, Michael. 64. And then last would be 128. So you guys said the strain B is multiplying by 2. So I love what lots of us said in the box where it said make a prediction. Most of you said strain B would be worse. Does anybody want to share their explanation? For extra credit, what'd you say, baby?
Because each minute their zombie is able to infect more.
Good, more persons. I love it. Each minute, he said, all the new zombies can go infect people. So that's going to spread a lot more than just the original being able to infect somebody. Did anybody say something different for extra credit on their test? No, is that what most of y'all was? What did yours say, babe? Okay. Okay, that's okay. So you understand B is doubling. Good. Anybody else want to share? I think most of you, when I was walking around, said strain B because all the new zombies can infect people. So that's good. Okay. This is why I wanted you to do this. So I hope we're listening. I literally made this worksheet in first period for y'all because y'all acting like you can't figure out a pattern and write an equation. All of you that didn't do your homework last night, you're acting like you can't look at a table, find a pattern, write an equation. So let's talk about it. These tables down here, these is for you. You're welcome. Let's look at them. Strain A. What kind of pattern do we have for strain A?
A linear function?
It's adding, which means it's what kind of function?
Linear?
Very good. Y'all listen. That is a linear function. Now, y'all gonna make me lose my mind up in here if you act like you can't write the equation of a line. Listen, y'all were writing the equation of a line wrong on your homework. Those of you that did it, we only had 7 people do it. If you're watching this later, that is awful, but okay. I lied, it was 8. Wow, that's so good out of 30. Holy cow. Yep. 10 of them never do anything. So they're invisible to me at this point. Yeah, they're invisible. I'm recording, so I probably shouldn't say anything meaner, but Jay said, oh yeah. All right, listen. Everybody listen. How many zombies did we start with in strain A? I know y'all didn't just say 2. Read the flipping table. How many zombies did we start with? 1, y'all. That is the base. Y'all know a linear equation should be mx plus b. So the fact that y'all couldn't do the linear ones last night, that really upset me. If you mess up on the exponential, that's okay. It's new. We're going to learn about it more. But the linear, y'all, the base is 1. So you should have said plus 1. Now, what is the linear one adding each time? 3. So that means the slope is 3. Your linear equation for this table should be y equals 3x plus 1. I'm going to move it so you can see. Here you go, Bob. Okay, you could also say, that's a great question. Everybody look. Curtis, couldn't we also have said y equals 3 over 1x plus 1? Yeah, that's the rise over run. This side's going up by 3. This side's going up by 1. I just wrote 3 because 3 divided by 1 is what? 3. But you could have put it either way. But listen, y'all didn't put it that way. Y'all talking about some 3 was the base and 1 was the slope. Gonna make me lose my mind up in here, up in here. Y'all the ones acting like fools though. Do we understand how to write the equation of a line? You should be able to look at that table, see that it's adding and say, okay, that's a mx plus b, that's a line. Does that make sense? We're gonna try more in a minute. People at home, any questions on strain A? Gwyneth said no. Jayla, Tyree, Jasmine?
No.
All right, so let's look at strain B now, y'all. Because again, y'all gonna make me lose my mind for real. Strain B is multiplying. So I hope we're all looking. If it's multiplying, what kind of function is it?
An exponential.
Exponential. Very good. You could have abbreviated. Some of y'all put a big E. That's fine with me. I know what you're talking about. That is exponential. I hope we're writing this with me. This ain't for me. This is for y'all. Oh no. Then they started writing Kira. Woo. Don't worry about the linear one. You can copy that in a minute. Get with me on the exponential one. What does the equation of an exponential function look like? What did we learn yesterday?
A times bx.
Good. A times b raised to the x. For extra credit, and I'm going to wait till everybody's listening so it's a fair playing field. We're all listening, right? Some of y'all perked up when I said extra credit. For extra credit, what does the A stand for?
The initial amount.
The initial amount. Very good, Gwyneth. What does the B stand for?
The factor.
Good. The base, which is what you're multiplying by, aka the factor. And an exponential, what goes in the parentheses is whatever you're multiplying by. So let's talk about it. What was my initial number of zombies for strain B? 1. Who said 2? No. Initial, where x is 0, children. How many zombies did you have? 1. So the initial is 1. What are we multiplying by each time?
2.
2. So that's what goes in the parentheses, and you just raise it to the x. Y'all were making that homework way harder than it was. We did one just like this in class, but some of y'all zoned out by that time. So do we understand the difference between a linear table and an exponential table? Do we understand the difference between the equations? Linear is mx plus b. Exponential is a times b raised to the x. I need yeses or nos or something. Yes. Okay. She added a cough with hers. That's great. All right. Listen, look. Of course I don't have it. Why would I? Ugh. ADHD sucks. It's fine. All right. If you graphed these, we're just going to talk about it. If you graphed these ordered pairs, actually, I'll go ahead and do it for y'all really quick. I want you just watching. You do not have to do this. So I should see all eyeballs up here. Strain A has the point 0, 1, 1, 4. So I'm going to go over 1 up 4. 2, 7. 3, 10. Do y'all see what I'm doing here? Okay. Do I need to keep drawing the stuff?
No.
No. Fantastic. Great. Okay. And also, why didn't that work? 0, 1, 1, 4. Oh my God, because I put 2, 1, 6 because I'm dumb. Screw. 3, 10, 4, 13. All right, look at this. If you connect strain A, and y'all know I'm not a good drawer, Skylar, you ain't looking, baby. Look up here. If you connect them and you use a ruler, that's going to end up making a straight line. I know mine didn't. It's because I suck at art, and y'all know that about me. All right. Strain B, if you went and you graphed it, I want y'all to watch. Strain B has the ordered pair 0, 1, which will be all the way down here near the bottom. 1, 2, 2, 4, 3, 8, 4, 16. I'll be like up here. 5, 32. All right, we're getting big. 6, 64. We're getting really big. 7, 128. That don't even fit on the graph. Y'all look at these points when I try to connect them. What kind of shape is that?
A J.
It looks kind of like a J, kind of like a roller coaster, right? Okay. Exponential functions are going to either shoot up really quick or come down really quick, just like a roller coaster. Yes, we're about to talk about that today. Extra credit. I like where you're going. Good. So listen, linear functions, there aren't very many things in real life that can be measured by a line. Because how many things do y'all know in real life that change by the same amount every single time? Not much, yeah. Exponential functions, you can use those in real life a lot. So I'm going to go with what Tay said really quick. I hope we're all still listening. An exponential function, what did you say is a use of it? Like business models. Do y'all know about the stock market? Take your AirPod off because I can hear your music up here. It's somebody's. AirPods phone should be up. Don't make me take them. Y'all gonna make me be the police today. Did y'all hear Tay's example? Because it was great. Stock market, businesses. The stocks shoot up or they shoot down. It just depends on the day, right? What's another real world example of an exponential function? Remember, participation gets you extra credit. Oh, I know. Maybe. Depends. I could see it being either way. I know some of y'all are in world history right now. And I know y'all learned about this thing called the plague. Oh, you should have. What happened in the Black Plague?
A bunch of people died.
A bunch of people died, and they died how? Real quickly. Let me talk to you about the Black Plague. The Black Plague spread way faster than coronavirus. Like, I could have it and not know it and even be near Kiara, and she'd get it, and both of us would die within a few days.
Oh, yeah, I heard about it.
Yes, the Black Plague, that was exponential because as soon as you caught it and gave it to all these other people you didn't know you had it, then you all died because they didn't have medicine back in the day to fix it. Think about COVID when COVID first started. So let's talk about it this way. This is a great example. COVID started last March. Can y'all believe that? It's been almost a whole year of these stupid things. I'm so over it. I'm ready to see y'all's beautiful faces again. COVID started last March. We started with one case in North Carolina. Do you know where that case started? Raleigh. Good job. It did start in Raleigh. Listen, that one case in Raleigh turned into 40 cases in North Carolina in 2 days. Those 40 cases turned into like 300 some cases in the next day. So do y'all see how COVID spreads exponentially? A week later, we were all on lockdown. Y'all remember that? The only thing open was the daggone gas stations and the grocery store, and that's it. Yeah. So that's exponential. What about, let's see, have y'all learned about the Holocaust?
Yeah.
Yeah, the Holocaust, World War II. Oh my
Yeah.
God, I'm gonna educate you today. World War II, a lot of people died really quickly because Hitler was a maniac. I would have survived.
I would have.
No, I really, you would not have. I'm serious, you wouldn't have survived because of the color of your skin. It's not even that I'm white, have blonde hair and blue eyes.
Me too.
Those people were pure and literally killed everybody else because he's freaking insane. He was a maniac. It's fine. He got killed too. So bye. Bye, Felicia. That was exponential. Think about when they come out with a new pair of Jordans or a new pair of whatever shoes y'all want to talk about. As soon as those shoes hit, what happens?
They do.
They go right out because everybody goes and buys them really, really quickly, right? Exponential. Do you see how many like real life things we can do with exponential functions? That's why it's my favorite. This is the one unit that I'm going to teach y'all about that you can go take out in the real world. That's sad that it's just one unit. I wish I got to pick what I taught y'all because I'd teach y'all lots of life stuff. This unit, most important unit you're going to learn from me. Capiche? Any questions on exponential functions and how we're going to use them? We're about to go into vocab and finish that up and finish up notes. That is fantastic. Everybody listen. The initial is not 2, and a bunch of y'all put 2. A bunch of y'all put 1, and I'm not sure where you got 1 from because I don't even see a 1 in the table. So listen. The initial is not 2 because the initial is where x should be 0. So this is why I did those ones in the notes. You need to work backwards and figure out what came before 2. Because whatever comes before 2 would match up with 0, right? How do you work backwards to figure out what came before the 2? Yes, divide by what, y'all? Y'all are so smart. So listen, 4 is your pattern. The opposite of multiplying is to divide. So to figure out what came before it, we're going to divide by 4. Y'all look, what is 2 divided by 4? 1/2. Very good, so everybody listen. The initial, what would match up with 0 would be 1/2. What are we multiplying by each time? 4, that's the factor, and we raise it to the x. That was the hardest one up here. If you struggled on that one, I get it. I understand because it's a new topic. You struggled on the front side, I was a little concerned. The notes for today are the same topic as yesterday, so we're not labeling anything different. We're just going to pick up where we left off yesterday. So I'm going to flip to my page, and we just have a couple of different things to learn about, not many. So I'm going to pick up where I left off yesterday. Yesterday, we talked about what the equations and the tables look like, correct? So what do you think we're going to talk about today?
The graphs.
The graphs. You're not actually going to have to graph. You're welcome. That's so nice of me. I'm going to let you use Desmos for graphing when we get there next week, okay? Yeah, you're welcome. You're welcome. Shh, listen, listen. I'm going to let you use Desmos to graph next week. But we do need to talk about what the graph should look like. Does that make sense? If you are getting a straight line, should it be exponential?
No.
Curtis, I hope you're paying attention. If your graph looks like a straight line, it ain't exponential, it's linear. What did we say these graphs should look like?
A J.
Like a J, very good. So I want y'all to draw these. It doesn't have to look exactly like mine, but we're going to draw them. We want to make sure we know what the graphs look like. And I am going to draw 2 different examples. Do y'all remember what I said the graphs could look like? They could either go blank really, really fast or blank really, really fast. Yes, up or down. Everybody look. Curtis, pay attention. Okay. Everybody look. I already said that, which tells me you weren't listening. Lord, you done told on yourself. The graphs of exponential functions can go up really fast or down really fast. They look like this. So I'm going to pause and give you a second to copy them, and then we're going to talk about them. Make sure I'm recording. What do we notice about both of these graphs? Tell me some things you see. It's a J. They both are J-shaped. They have to curve. If it doesn't curve, if it's straight, it ain't exponential. What else do you notice? The pink one is going up, so let's write that. Good, Kiera. The pink one is increasing, right? So what can we say about the green one? Good job, y'all. It's decreasing. What else do we notice? There's something important. No, you're okay. You say, and then I'm going to pick up where you just said. You. They are functions. Good. That's one thing I wanted you to notice. So everybody listen to what Tay said. If you drew vertical lines down them, Curtis, you watching, baby? All right, look up here. If you drew vertical lines through them, it would only touch once, right? So these are functions. Hence why it's called exponential functions. There we go. Now, what did you say? Because I liked that too. That was the second thing. Both of them, everybody listen, both of them touch the y-axis. What do they not touch? The x. This is something super important. I want you to listen very carefully. We're all listening, right? Okay. Exponential functions, I told you, are like real world functions, right? So let me ask y'all a question. When we're talking about the new Jordans that come out, are they ever going to be at 0? No. If I talk about people who died in the Holocaust, let's use our brains, because last semester I had somebody say something really idiotic. I don't have a nicer way to say it. When we talk about the Holocaust or the plague, did everybody die? Did they hit 0? Duh, because there's still people here, right? I had to explain that to one boy, and I was like, oh, Lord, okay. No, they didn't hit 0. When we talk about the stock market, like Tay said, do stocks ever hit 0?
No.
No, if they did, y'all, none of us would have any money. That's it. It's gone. So can exponential functions ever hit 0? No, they should never touch 0. So listen, I drew them both above the x-axis. They can never hit 0, and they can also never be what? Negative. Do we have negative shoes in the real world? No. Do we have negative people in the real world? Not a negative number of people. Y'all talking about some, yes, y'all are some of them. We do not have a negative number of people. Do we have negative money? No. Okay, that's you owing somebody money. You still owe them a positive amount of money. How can I have negative $5? That means I owe Chandler 5. Does that make sense? You can't have negative things in the real world. So these exponential functions have to be above the x-axis. Does that make sense? Are y'all sure? Because every year I got a kid drawing them into the negatives, and I'm like, that automatically ain't right. Something ain't right. All right, I'm gonna pause. I got a good question. Quiet today. This one is going up. Let me ask you a question. Amaya, if you were reading a book, how would you read it? Which direction? Yes, she said like this. Left to right. When you read a graph, you read it left to right. When you read a table, you read the left side first because those are the x's. So look, if I start on the left and move to the right, it's going up. Start on the left, move to the right. This one's going down. So what's your question? Words for this. If you have an exponential function that is increasing, does anybody know what we call that? What's another word you can think of for increase? Just start throwing out words. Going up. I heard adding. It's not adding because we know
Growth.
exponential functions are multiplying. What did you say?
Growth.
Oh, yes. She's so smart. Everybody look. No, that definitely ain't it. You need to write this down because she's on to something. Good job, Jasmine. Growth. Anytime our exponential function is increasing, we call that growth.
Oh, I know that.
Ooh, she said, I know she knows the decreasing one. What's the decreasing one? It is decay. Decay. So listen, yes, just like your teeth, when your teeth, I'm not kidding, I'm being serious. Listen, when your teeth are decaying, it's because the enamel on the outside of your teeth is going away really, really fast. I'm dead serious.
No, why did you say it like that?
It's a great example.
Okay, you'll tell a story.
All right, listen. Exponential functions that increase, what are those called? Exponential functions, this is exactly why y'all didn't do your homework. It's funny to me how the people cutting up are the ones that didn't do their homework. Don't make me roast you, pay attention. Exponential functions that increase, what do we call them? What did we just write and put a box around? Holy crap, growth. Exponential functions that decrease, what are we always gonna call them?
Decay.
Decay. Do you guys think if I gave you a graph, you could tell me if it was growth or decay? Okay, so let me show you the one other thing for today, and that's it. We're gonna be done. If it is growth, I'm gonna stick to my colors actually. I hope we're ready to write. Michael, if it is growth, the factor will always be bigger than 1. Bless you. If it is growth, the factor will always be bigger than 1. So if it's decay, now be careful. It's not going to be negative because I always have a kid say, oh, it's negative. No, no, no. We already said they have to be positive. It's going to be less than 1. So let's talk about it. What kind of numbers, Curtis, what kind of numbers are less than 1 but not negative? Not 0 either. It shouldn't hit 0. I don't know why y'all are saying 0. We talked about it. Say it again. Yes. Look, write this down. She said fractions, and she is correct. So example, remember on the homework we had one where the factor was 1/2? That's decay. That means it's going to go down. Because if you're splitting a pizza in half, you're making it smaller. So it's going to go down. Kind of. It's not a rise over run because it's not linear. So let me give y'all a couple of examples to make sure we're all on the same page, and then I'm going to turn you loose on your classwork because you will have learned what you need to know. And we're all going to do our classwork today so that we don't fail this upcoming test. I mean, some of y'all. Example 1. That don't have anything to do with the lessons. Hang with me. Y'all blurting out a lot of crazy stuff today. All I want you to do is tell me if it's growth or decay, and not yet. Do not blurt it out. Y'all are being a little cray-cray. I feel like I'm training my dogs again. Freshmen are like doggies. Y'all like little puppies. Got to train you. Nothing to do with the lesson. We'll come back to it in a minute. Look at the factor. What is the factor of this equation? 4. Thank you, Chandler. Some of y'all were really about to say 3. Good job, Jay. Good job. You 3. He held it up, baby. He went like this. He don't need to speak in front of y'all. Y'all be saying crazy stuff. 4. The factor is 4. Is 4 bigger than 1 or is 4 a fraction? It's bigger than 1, which means this is what kind of exponential function?
Growth.
Growth. That means this graph would shoot up. Does everybody agree? You can draw the J if you want, so it helps you visualize it. That's fine with me. Let me give you another one. What if you have like the one we had off of the homework? I'm trying to remember what it was. I'm just going to make up a different one. Don't blurt it out. What would this second one be? What's the factor? 1/2. Very good. It's not 5. If you tell me it's 5, I'm going to be upset. The factor is 1/2. That's what we're multiplying by. Is 1/2 less than 1? Yeah, it's a fraction. So this kind of exponential function would be called what? Decay, which means if we graphed it, very good, Jasmine. If we graphed it, it would be going down. Now, let me help y'all out just a little bit because I have some of you kind of looking at me confused. And for the sake of my example, are you guys okay if I make this a bigger number, like 8? Yeah, sure. Great. Everybody pay attention. You don't have to write this unless you want to. Okay? I want to review though. This will help you with your delta math for today. What's the initial for this example on the left? The initial is 3, which means we start at 3. So when x is 0, the y is 3. Do y'all agree? Okay, what are we multiplying by each time in this one?
4.
4. So what would come after 3?
4.
What'd you say? No. Why are you saying 4? I said, what are we multiplying by? And you guys said 4. And then I said, so what would come next? And y'all fools said 4. Can you say that again? 12. Y'all got me messed up. 12. Do you understand it? Okay. It's okay. You just had me worried. I don't think you really listened to the question. I think you just answered. What would come after 12? No, we're not multiplying by 2. All of you that just said 24. We're multiplying by 4. So what would come next? 48. Dang, it just took some of y'all a while. We're multiplying by 4 each time. All I'm doing is listing out the numbers. Do we understand that? Okay, let's try with this next one and see if y'all can get it. What's the initial? 8. Now, what are we multiplying by each time in this one? 1/2. Good. Am I going too fast? I see a lot of y'all still writing. Are we okay? You ain't writing. I hope you with me. We start with 8. What are we multiplying by each time? 1/2. Y'all, what's half of 8? Good. 4 would be next. We'll let her in 1 second. What's half of 4? Good. Then 2. What's half of 2? 1. So do y'all see how the initial is where you start? The factor is just what you multiply each time to find the next numbers. Yes. This, perfect. Stop. Everybody listen to what she said. Are y'all listening? The pink one, what are the numbers doing? Look right here. Stop looking at the door. I'll let her in a second. The pink numbers are growing. They're going up. What are the green numbers doing? Going down, which is why it's called decay. Did that help it click? Okay, I'm done teaching for today. We're going to teach some more on Tuesday. You have a Delta Math classwork and you have 20 minutes. You should finish it. You do have to do some work, so I'll write those problems on the board. My Zoom kiddos, you guys know which ones need work on Canvas, so I'm going to stop recording. Y'all are more than welcome to hang out up here while you work, okay?